Attention civilians, I am General Science, and today we march into battle. This battle is between two liquids who refuse to work together and become one. I am here to defeat their defenses and bring these two together. It may be difficult, it may be messy, but I believe it can be done. Can I conquer and mix these two? Most of the time, water and oil will not mix, but I will be using a new battle strategy. When other substances are added, will water and oil mix? My hypothesis for this battle is that when detergent is added to the oil and water, the mixture will become homogeneous. Now, to introduce our liquids.
I am water, a transparent, odorless, tasteless liquid, a compound of hydrogen and oxygen, H2O. I can be rain, lakes, oceans, and ponds. I am a water.
Thank you, Rain. Have a seat. And then, our next component, we have oil.
I am oil. I am a non-polar substance. Classes of chemical compounds that may be otherwise unrelated in structure, properties, and uses. I am hydrophobic and lipophilic. I can be viscous, liquid at ambient temperatures.
Right, thank you, oil, our non-polar. So we have our polar substance and we have our non-polar substance. Let's see how this battle goes. So, why won't these two mix? Water is a polar liquid and will only dissolve with other polar liquids. It is polar because it has a bent shape in which the negatively charged oxygen atoms and the positively charged hydrogen atoms are on separated sides of the molecule. Non-polar liquids, usually organic molecules, mix well with each other. So, what battles have I decided to use during this battle? Let's find out. First, we have, ready? A jar. 6 of them, to be specific. 6 jars. Then, we have our polar liquids. We have water and we have bleach. Then we have our non-polar. We have vegetable oil and motor oil. Then we decided to add a few things to make it fun. We have some food coloring, some dish soap, and some applesauce sometimes. Let the games begin. Alright, so first I'm going to show you how our polar substances will combine and mix. So first we're going to have our water. Fill it up about halfway. Then we're going to add bleach. Work harder, soldier. No weakness. Use your strength. Wrong way. Okay. About 3/4 of the way up is where we'll add the bleach.
Where?
Right here.
That bleach is
Thank you very much. Now, please tell me, water, what happens with the bleach and the water?
I don't know.
Can you tell the difference between the two liquids?
It changed color.
Change colors. But are they separated or together? So it created one liquid substance. Okay. So as you can see, a polar substance and a polar substance mix together. Now, nonpolars. First, we are going to have our vegetable oil. Please, sir, grab the vegetable oil. Come on, use those muscles.
Oh, my hands are sweaty.
A soldier never gives up. Thank you. Now we need just a little bit of motor oil.
Why do we use motor oil?
Because motor oil is a non-polar substance.
Oh.
So we're just showing an example that they mix together. Okay, that's good. Now, sir, please mix the two.
One next time. I love it. It's blue.
All right, oil, please tell me what these two have done.
Made a new color, and they're together.
So they come together as you two should come together. Okay? As you can see, non-polar substances come together. All right, so let's find out when we mix these two, water and oil. All right, so first we're going to try it 2 different ways with hot water and cold water, just to see if there is any difference. Okay, so our hot water is already heated and pretty hot to touch. So again, you want to fill it about halfway full. You cannot drink it. Don't drink it.
Yes,
Okay.
you may not.
Okay, as a valuable lesson, please do not eat your experiments. They can be very dangerous. Okay, hot and cold. So we have them filled about halfway full. Now we're going to add our oil. Okay, water has been added. Oil, please add.
Mom.
Actually, I think we should make it a little bit more fun. What do you think?
Sure.
War isn't fun without a little creativity. How about we add some color to these babies?
Yeah, I'm not a baby. Well, that's mine.
All right, so red has been chosen and blue has been chosen for hot and cold. Please go ahead and put a couple drops into each one. Maybe 4 drops. Okay. Then please use. Sorry. Okay.
You said in each one.
Very good job. So we're gonna have a purple and yellow. So please grab your spoons and mix your waters, please.
Why do you do it very much? Okay, that's perfect.
Okay. Spoons aside, gentlemen.
Looks like juice.
Now let's add our oil, please.
I'm gonna check on the oil.
Yes, sir. To about right here. Okay. Okay. Let me put the oil down. Now, water, please tell me what you observe with the first reaction.
It's not mixing. The oil is just floating on top of the water.
Okay. Do you think the same thing?
Yes,
Oh, we agree. Maybe there is a hope for that. Okay, please take your spoons and without making a disastrous mess, stir them together to make them blend. Keep stirring, gentlemen.
Like you can see mine.
All right, now please put your spoons aside.
I'm sticky now. I'm sparkling.
Put them aside. Now, please tell me what you are noticing at this moment.
They're not mixing. That mine is mixing and making a lot more sparkle.
And sparkles? Okay, so let's let these sit for just a couple minutes and see what they decide to do. Okay? Can you tell the difference between the hot and the cold? Is there anything different?
That one's hot and one's cold.
This one's mixing more. But this one, the oil is just floating on top, not mixing.
Okay, so this one created a little bit more bubbles and seems to expand it a little bit. Okay, let's find out what happens to those in a little bit after sitting. But it doesn't look like they mixed very well, does it? Okay. All right, now please have a seat and we are going to try a new strategy. So let's set this aside. Now we need these halfway filled with water, please. Muscles. Thank you, sir, and thank you for your input, oil. Now, place the water aside. We are done with it at this moment. Now let's add different colors this time. How about yellow and green?
I like green that side.
So we're doing the exact same process. We're starting with our water, and we're adding our food coloring for fun. Okay, that's good. Take your spoons and please mix. Yes, you can use any type of clear container to use these in.
Look at mine.
Generally tall, skinny, it's preferred. Okay, that is wonderful. Thank you very much, Sherman. All right, oil. Now you need to add, please. We're adding our vegetable oil again. Same water, same vegetable oil. Now both of these are cold water. They are not hot. Let's add a little bit more oil
Like the diamond.
to make it even more difficult.
Sounds fun.
All right. Okay, so looking at the reaction, did these two mix or are they separated?
Separated.
They are separated. Go ahead and stir. All right. Weapons aside, please. Okay. Now, for the secret weapon. Ready for this? Dish soap, please. Every mom's miracle worker. Now, please squirt some into each jar. Thank you. Great sound effects. Perfect. Now, please mix your jars again. side, please, and tell me what you observe. Spoons this up.
A spinning.
Now that it has stopped spinning, what does it look?
It's mixed.
It's
It is mixed.
Oh.
Yes. So our lovely Dawn dish detergent has created a way for them to mix. So why? Why is that? So soap is a surfactant, which means that some of the properties in the soap molecules are the same as water, and some are the same as oil. So the natural place for the soap to sit is between the two, making a bridge between them. This breaks the oil and the water molecules into smaller and smaller groups, and they appear to have mixed. For example, see our difference? Oil and water mixed. Okay? So,
It's magic.
to recap our battle, water mixed with other polar liquids and oil mixed with non-polar liquids. But on their own, they do not mix. The two are immiscible. We were, though, able to create an emulsion between the two liquids when we added the dish detergent. The detergent acted as a mediator and bonded the two sides, bringing them together. In conclusion, water and oil can mix. Besides to prove all of those other theories wrong, that they can never mix. They can mix, and they will mix when we make them. Now, water and oil can mix if you combine them with a surfactant. Kids, please. Emulsion. They come together. Now, we're not done just yet. If you think we're done, no way. Because that wasn't the fun part. That was just the interesting part, showing you what happens. Now it's time for a little bit of fun. What do you say, boys?
No!
You ready for some fun?
I want to make a lava lamp.
All right. Did you know that doing this process, you can create a lava lamp?
No.
Okay? Take your 2 jars from before. All right. So we have.
Hey, that was mine.
You two are combined together as one now. All right. So we have these 2.
Boom.
Okay. Now we're going to add something pretty exciting. We have Alka-Seltzer tabs. Yes, everybody loves these. Delicious, right?
No.
Okay, so Alka-Seltzer tabs react with water to make tiny bubbles of carbon dioxide. These bubbles attach themselves to the blobs of colored water and cause them to float to the surface. When the bubble pops, the colored blobs sink back to the bottom of the bottle. And the whole thing starts over again until the tab is used up. So, let's try it. What do you think is going to happen, sir? Okay, so let's just try one tab at a time, please. Please tell me what you observe is happening.
There's a bunch of bubbles. There's a bunch of bubbles floating up and making the top black. Nothing's happening with these.
Okay, let's go ahead and add some more Alka-Seltzer tabs.
I'm gonna add tea.
Okay, if you gentlemen wouldn't mind, would you take your jars and hold them up for everybody to see what is happening? Go around and get closer so they can get a close-up view.
I look like an old man.
Can you see the oil rising to the top and then falling again?
Yes, ma'am.
Okay, let's try something even cooler. Liam, would you please shut the lights off? Kaden, would you mind grabbing a flashlight?
I used this in the beginning of the video.
Okay, gentlemen, let's see what happens when we add a little bit of light. Here are some more Alka-Seltzer tabs.
Do you put them in?
And so we'll do one at a time and hold your jar on top of the flashlight. So I will hold the flashlight and put your jar on top. It's a little difficult to see in the video, but very cool in person. Please add some more Alka-Seltzer tabs. Now let's try
That's
this
it.
one. Would you like to add your Alka-Seltzer tabs, please?
Kaden, let me do it.
Let's try this. Maybe we'll dim the light just a little bit, but still include the same effect. Yeah, I think that almost made it brighter.
Add a bit.
Yes, sir.
That is amazing.
Oh,
It's
really?
I don't want the purple one. The red one's mine because I made it.
Okay, that concludes this battle. I think we have conquered and definitely succeeded. Thank you. Thank you to our wonderful Water, Kaden, Boyle, Liam, Sergeant Science, Sarah. Have a wonderful day and do more science.